back to my series on Kepler's laws, and we're on the last one, the third law. This one is suspicious because based on the notes recoveries of Kepler, we're not exactly sure how he came up with this conclusion, but nonetheless, we shall continue. The squares of the orbital periods of planets are directly proportional to the cubes of the semi-major axis of their respective orbits. What does that mean? If you're looking at an elliptical orbit, the radius of the orbit changes at every moment in time, but the maximum one is usually referred to as the semi-major axis. The minor one is the one that goes usually straight through the smallest section. In my diagrams, it's usually the vertical. What this law says is that if you observe two planets in orbit around the sun, they have a unique relationship with the time it takes to complete an orbit and the distance they are from the sun. If you square the time it takes for the Earth to orbit around the sun over the square of the time it takes Mars to orbit around the sun, T1 over T2 to be squared, it is proportional, equal to, the semi-major axis of the Earth to be cubed over the semi-major axis of Mars to be cubed. Hence the equation here. This is a really unique discovery, and it is debated to this day, how did Kepler come up with this? What's really important to note about all of Kepler's laws is that he made them via observations. It wasn't like Newton where he did it via mathematics, calculus, and calculations. Kepler observed the motions of the planets in our solar system. Happy orbiting!